Okay, hi everyone. Good morning. Okay, welcome back to the second part of the video for introduction to probability. So the first part I think should be okay. That one is the basic one for introduction to probability. Now let us continue with learning outcomes for 10.4. Let me start. Okay. So 10.4, this is the learning outcomes. Students should be able to, the first one is to understand what is conditional event. Number two is to find the probability of the conditional events. Conditional is the event that happen with a condition. Okay. Okay, so this is the definition. When an event occurs with a condition that another event has occurred, then the event is a conditional event. For example, the event that a girl is chosen knowing that the students wear spectacles. Okay, meaning that we want to choose a girl, then we know that she is wearing spectacles. Okay. Second example, two balls are taken from a box containing several red and blue balls without replacement. Okay, the event that getting the second ball depends on the first ball. Okay, for example, I have 4 pens in a box: yellow, blue, black and gray. Okay, I want to pick up 2 pens. Okay, one by one without replace it. Okay, so when I pick the first one, okay, let's say I'm picking up without I know what is the color that I'm picking up, yeah, from the box. So the blue one, let's say I pick up the blue one, so the probability for this blue is 1/4. Okay, since I want to pick up 2 pens, so this blue pen I didn't replace back to the box, so I put it away. Okay, now I'm picking up my yellow pen. Okay, so this yellow pen, the probability will be 1/3. Okay, 1/3. So the probability of picking up the yellow pen for the second event will be depends on the probability for the first one as well. Okay, can understand kan? Okay, kita akan tengok. Let us continue with the definition first. Okay, conditional probability is the probability that an event will occur given that another event has already occurred. Okay, so for events A and B in a sample space S, we define the conditional probability of A given B by this formula. Okay, so you have to memorize this formula. Yeah? So this vertical line we call as given that. Okay, given that. So how we read this? Probability of event A given that B already happened is equals to PA intersect of B over PB. So how we memorize this? Very easy. The numerator will be the intersection between A and B, and the bottom one will be the one at the back. So let's say I want to find the conditional probability of B given A. So what happened will be PB intersect A over PA. Okay, the one at the back will be at the denominator. Okay, I think that one should be clear. And we read it as PB given A equals to PB intersect of A, where PB intersect of A is also equals to PA intersect of B. Okay, terbalik pun boleh. PA intersect B is equals to PB intersect of A, also the same. Alright. Okay, let us see the example. The event A and B such that PA is equals to 1/4. Okay, and then PB is, PB is 1 over 3. PAUB is given by 5 over 15. So first we need to find the intersection between A and B. Okay, since we know from the first part of the video, what is the formula? PA union B is equals to PA plus PB, and we minus the intersection part one time. Because from here, we calculate the intersection part twice, so we minus it we minus one part of the intersection. So from here, when you rearrange it, PA intersect of B is given by PA plus PB minus PA union B, kan? So you just substitute the value lah, PA, PB, and find the value of PA intersect of B. And then this one also using the conditional probability, PB given A is equals to PB intersect of A over PA. Okay, the numerator is the answer from the first part over PA. PA is this value. Okay, I think this should be okay as long as you memorize the formula. Okay, next. This is the solution. Okay, you can check it later on. Okay, example number 2, A and B are two events such that PA equals to 1 over 3, PB equals to 1 over 4, PA union B is given by 1 over 2. So this is using the formula as well. Okay, gunakan formula tadi yang panjang tu, you just masukkan the value. So PA intersect of B is equals to PA plus PB minus PA union B. Okay, rearrange the term, kan? And then PA intersect of B coming from the formula as well from the first video. PA intersect of B is equals to, if you remember, A and B. So this is your A. B prime is outside. Okay, it is actually the A part, kan? Minus with the intersection. So PA minus PA intersect of B. Okay, so your B answer will be depends on the answer from A as well, because you have to substitute it here. Okay, so make sure you find the intersection value correctly. Okay. Okay, C, PB given A by using the formula. So PB intersect of A over PA. Okay, this is very easy. You just substitute the value, and PA given B prime is equals to PA intersect of B prime over PB prime. Okay, so the numerator, the upper part, you get from the answer from B, PB complement. Okay, still remember, PB plus PB equals to 1, kan? So PB prime, the complement, kan, will be equals to 1 minus PB lah. Okay, so 1 minus 1 over 4. So you will get this answer down here. Okay, the probability that exactly one of A or B will occur. What does it mean? Probability of A occur intersect with B not occur, or P A not occur intersect with B occur. Okay, this one, exactly one or B will occur. So or here, kan, plus lah. The first probability will be A occur, B not occur. Atau means plus, kan? B occur, A not occur. Alright, so you just substitute the value, then you get the answer 5 over 12. Okay, example number 3. In a college, 12% of the students are left-handed. Okay, left-handed. So we consider this as event L lah. So PL is given by 12% is 0.12. 15% of the students wear glasses. So this is G, we denote as G. So PG equals to 0.15. 3% are both left-handed and wear glasses, meaning that N is intersection. So PL intersect with G is given by 0.03. Given that a student wears glasses, find the probability that the student is left-handed. Given that is the vertical line though. Given that a student wears glasses, this is G and we denote as G. Find the probability that the student is left-handed, this is L, meaning that given that, okay, probability of given that G, okay, and then the one in front is L, PL given G, okay. So you just use the formula PL intersect of G over PG, okay. Adakan the value given. What is the probability that a left-handed student also wear glasses? So this is PG given L, even though there is no given that. Given that is always the keyword. PG given L. What is the probability that a left-handed student also wear glasses? Okay, so this is the condition. Left-handed kan? Condition. G happen when L happen. Okay, so PG given that L. So PG intersect with L over PL. Okay, then you just substitute the answer. Yeah. Okay, so this is the answer. Okay, number 4. A card is chosen at random from a set of 25 cards numbered from 1 to 25. So this is your S. S is curly bracket 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Close the curly bracket. What is the probability that the card chosen is a multiple of 4? Multiple of 4 given that it is greater than 15. Okay, so we let our event A is multiple of 4. So what is multiple of 4 in this case? 4, 8, some more, 12, 16, 20, 24 kan? And then B is greater than 15. Greater than meaning that it's just greater than, there is no equal to. So this is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so from here we can find our PA kan? PA is 1, 2, 3, 4, 5, 6. 6 kan? 6 over how many of them in the sample space? 25. And then PB, what is your PB? PB is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 25. Okay, so this is the conditional probability where you want to find PA given B. Okay, what is the probability that the card chosen is multiple of 4 given that it is greater than 15? So you need PA intersect of B over PB. So PB is this one, 10 over 25. And you have to find the intersection. What is the intersection here? 16, 1, 20, and 24. So 3 lah. So 3 over 25. So your answer will be 3 over 10. Very easy kan? 3 over 10. This one. Very easy. Okay, conditional probability can also be illustrated by using tree diagram. So a tree diagram consists of a number of branches that illustrate all the possible outcomes of a sequence of experiments or events where each event can occur in a finite numbers of ways. Remember, to find the probability, you must multiply along the branches. You have to multiply and add between the branches. After you multiply, you will have at the end, then at the end of the probability, when you add up, you will get 1. Okay. Okay, for example, as this one. Okay. This is the probability of getting A, this is the probability of not getting A. So the probability we will write here. And then second event, why we put it as here? Because they occur one after another. So B will happen given that the first already occur is A. So we will write it as PB given A. So the probability here will be PB given A. So when you multiply these two, PA multiply with PB given A, this is actually PA intersect of B, kan? It is coming from this formula, PB given A, PB intersect of A over PA. So when you multiply this to the left hand side, ni kan, this formula PA multiply with PB. So you akan dapat the intersection between B and A, or A and B lah. Okay, sama. And then this one also the same. When you multiply, you will get probability of B prime intersect of A. And then this one will be probability of B intersect of A prime when you multiply these two, yeah. And then this one, when you multiply PB prime intersect with A prime. Okay, the value, when you add these 4 values in the box, you will end up with 1 because the total probability will be equals to 1. Okay, remember? Remember this, how we get this probability, okay? Alright, a bag contains, let us see an example. Okay. Sorry, iklan. Okay, next, a bag contains 8 balls, 5 yellow and 3 red. A ball is drawn at random without replacement. Another draw is made. What is the probability? Okay, meaning that you have 8 ball, 5 yellow and 3 red in a box. Dalam box ini, you have 3 red. 1, 2, 3. Kan? And then you have 5 yellow. Pointer option in color, yellow color. 5 yellow. 1, 2, 3, 4, 5 inside a box. Okay. So a ball is drawn at random without replacement. Another draw is made. Meaning that you will pick up the ball one by one. Okay. After you pick up the one ball, you will not put it back. Okay. There is no replacement. Because, okay, so the first one, what is the probability? We can, to make it easy, you draw it in a tree diagram. Okay. So first draw, you have red and yellow, kan? So it is either red or yellow ball. Okay. So the first probability, when you take out red color, the probability is 3 over 8. How about yellow? Yellow will be 5 over 8. Okay, settle for the first draw. Second draw, since you are not put it back, okay, when you take out the first one red color and then second one, there is also 2 outcome for the second draw. It is either red ball or yellow ball. But now, since the first draw you already take out one red color, so second draw, the probability, okay, the probability to get red, given that the first one also red, is given by 2 over 7. Why I say 2? Because you already take one red color out. Then you left only 2, and remaining inside the box is 7 ball. Okay. If the first color is red and then second row you are taking out yellow, So the probability will be P yellow given that red is equals to 5/7. Understand ah? This is very easy ni. Kamu kena faham ni barulah senang buat that conditional probability. Okay, next. If your first row is yellow, so second row probability of red given that the first is yellow, so you will get 3/7, kan? And then kalau the first ball is yellow, so the second ball is yellow, so the probability is 4/7. I think that one should be clear, yeah? Okay, so now the question is, what is the probability that both balls are red? Meaning that you want to find P red and red. Red intersect with red. So the first choice is, this is red and red. This is red and yellow. This is yellow and red. This is yellow and yellow. Okay? Alright. So the first question is asking you to have red and red. So inilah. Alright. So we just multiply lah. 3/8 multiply with 2/7. Then you get the answer. That the balls are not of the same color. This one lah. Okay. So it is either you get red, yellow. Okay. Red at the first row and yellow at the second row intersection, or is plus probability of you get yellow first, second ball is red. Inilah, so you have to multiply. So 3/8 multiply with 5/7 plus 5/8 you multiply with 3/7. 5/8 3/7. Okay, then you get the answer. Or another method for B, okay, for B, what you can do is 1 minus probability of red and red minus probability of yellow and yellow. You can also do like that. You can check this, ya. Cuba kamu cari the probability of getting this and this and this and this. You add up, you should get 1. Okay. This one, you can check it here. But what happened, okay, by using the same example, but I change the question with replacement. Sudah saya punya pen. With replacement. Kalau saya kata the question is with replacement. Kalau with replacement, so what happened to your probability? Dia tidak berubah lah. It will not change. Okay, so if berapa tadi? 3 red and 5 yellow, taking out 2 balls with replacement. Okay, so what happened to your tree diagram? First row, red or yellow. So this one will be 3/8, 5/8. Okay. Second row. Still, the outcome is red or yellow. This one also red or yellow. Okay. Here, since we are saying that with replacement, so when you pick up red color from the first row, you put it back. So what happened to your second probability when you are taking red? It is the same, 3/8. Okay, 3/8. This one also 5/8. This one will be 3/8. This one also 5/8. Dia akan jadi gini lah. Okay. Alright. So these two cases are different. Okay. The first one just now, without replacement tadi, without replacement, We call it as dependent event. Dependent event. Why I say dependent? Because the probability on the second part will be depends on the probability of the first part. Dependent event, because it will be the first row will affect the probability of the second row. But in this case, the second one with replacement, we say it as independent event. Independent, because what happened in the first row will not take any changes in the second row. Okay, independent event. I think that one should be clear. And some more, the denotation, okay, R1, Y1, it is up to you. Just now I didn't put 1 or 2, kan? But it's up to you. If you want to denote red 1, meaning that is the first red color in the first row, and R2 is red color in the second row, also can, it's up to you. No problem. Okay. Okay, conclusion in 10.4, you have to memorize this formula. Okay. It is a must. Very easy to memorize. PA given B, the intersection is always up here. And then the denominator will be, depends on the one at the condition at the back. If I change it to PC given D, so it will become PC intersect of D and D, because D is at the back. Very easy to remember, kan? Okay, so this is what we will be talking about independent just now, kan? Dia related dengan yang the 10.4 independent event. So 10.5 we will understand what is independent events and the probability of the independent events. Okay, so this is another example. Let A be the event of resulting of flipping a fair coin, H and T, kan? And B is the event of the number obtained when a pair of dice is rolled. Okay, so you have 1, 2, 3, 4, 5, 6. Okay, so these two events are unrelated. Whatever result you get from flipping a fair coin, H, doesn't affect your rolling dice. Okay, so if we do it simultaneously together, okay, still the events are said to be independent. All right, because they are definitely unrelated. The previous example just now, they are related because you are picking up from the same thing, picking up balls, kan? But then we split it to two types since because of the condition, with replacement ataupun without replacement. Okay, so this is what we call as independent. Another example of independent. Okay, so from the probability rule for conditional event, all right, this is coming from the previous 10.4. So PA given B, you have PA intersect of P over PB, where you can rearrange it, you bring it here, and then it will be multiplication, kan? Okay. So if A and B are independent event, it means that the outcome of one does not affect the outcome of the other. Then PA given B equals to PA and PB given A is PB. Macam gini ya. If we have two event A and B, we do it simultaneously ya, serentak. Okay. The first A and B, and then this one A and B. Okay, so here is PA, here is PB. So this one nih, yang ini PB given A. PB given A, since B is independent to A, so ini will be PB lah itself. Dia punya probability sendiri. So that's why we can say here PB given A is PB. Sama juga di sini. Yang di sini kan. PA given B, okay, is given by PA. Dia punya probability sendiri. Okay, so dia akan dapat inilah. Alright, so PA intersect of B is equals to PA given B multiplied with PB. So since PA given B is PA, so we can say that PA multiplied with PB. So for a special case independent event, PA intersect of B is equals to PA multiplied with PB. Okay, formula ini you have to memorize, because sometimes we can ask you show that A and B are independent event, then you can show the value are equal. Okay, alright, remark A and B are independent event, then A given B prime, A prime given A prime and B, and A prime and B prime are also independent event. Kalau A dengan B itu ada independent, so you can have this as well. Okay, let us look at the example. Suppose two event A and B are independent, given PA equals to 0.4, PB equals to 0.25. Okay, A and B are independent, calculate. Calculate lah this one. So this is multiplication lah. PA multiply with PB. And then this one, how to find? Use the initial formula from the first video. PA plus PB minus PA intersect of B. That's why I'm saying to you, you have to memorize the formula. Okay? So PA intersect of B coming from the first the first part A. Question A kan ini. Masukkanlah. Okay? Just for an independent event, yeah? If not independent, or the question didn't say that this is an independent event, then you cannot use the formula tadi ya, yang PA multiply with PB. Okay, A, B, C are three independent events such that A and B are independent, whereas A and B are mutually exclusive. Mutually exclusive. Masih ingat tu apa? Alright, A and B. So given that PA equals to 0.4, PB equals to 0.2, PC is 0.3, and PB intersect C is equals to 0.1, find PA union B. PA union B is PA plus PB minus PA intersect of B. Okay, this is given, this one you have to find. PA intersect of B, this is saying that A and B are independent, so you can have PA multiply with PB. Okay, so PC given B is PC intersect of B over PB. C intersect B also equals to PB intersect of C. Kalau terbalik pun sama, dia commutative. 0.1 over 0.2, then you get the answer. How about this one? PC intersect of A prime. PC intersect of A prime. Guna formula of conditional probability. So C intersect of A prime over PA prime. So PC, okay, so PC over 1 minus PA. Ni properties of complement tu, yang PA plus PA prime equals to 1. So PC, macam mana dapat PC ni? From here, C intersect A prime. Because dia kata tadi apa? A and B are independent, A and C are mutually exclusive. Masih ingat tak mutually exclusive tu apa? A and C are mutually exclusive. Maksudnya A dengan B itu tidak overlap. Part ni di sini dia tidak overlap. Okay, so PC intersect of A prime, so definitely itself lah. Ni kan, so dapatlah C di sini. Okay, sometimes it is good for you to sketch dia punya Venn diagram as well. So PC over 1 minus PA, so just masukkan the value, then you get the answer. Okay, how about this one? A mathematics puzzle is given to 3 students, Amin, Ali, and Abu. From the past of experience, known that the probability of Amin, Ali, Abu will get correct solution are 0.65, 0.6, 0.55 respectively. If 3 of them attempt to solve the puzzle without consulting each other, find the probability that the puzzle will be solved correctly by all of them. B, only one of them will get the correct solution. Okay, so kamu kena denote, okay, based on the probability given. So this is the probability will get correct solution, Amin, Ali, Abu. So we define lah. A, Amin answer correctly. B, Ali answer correctly. C, Abu answer correctly. And then if 3 of them are solving the puzzle without consulting each other, find that it will be solved correctly by all of them. Okay, the puzzle are solved by all of them correctly. Maksudnya dia overlap lah. Okay, A and B and C correctly solved. And then tadi statement dia, they are solving without consulting each other. So maksudnya they are independent by themselves. So we can multiply macam beginilah. So PA multiply with PB multiply with PC, so you get this answer. The events that only one of them will get correct solution will occur. Okay, the next solution, only one of them will get correct solution. So it is either Amin answer correctly and lagi 2 orang tidak, atau means plus Amin jawab salah, intersect with Ali answer correctly, intersect with C prime, Abu did not answer correctly. Or is plus, A prime intersect B prime intersect with C, Abu answer correctly. Okay, so you just add up all together. Mutually exclusive. Okay, mutually exclusive where your A, B, and C did not overlap to each other. Kenapa dia tidak mau tulis ya? What happened? Pointer option, pen. Ini. Mutually exclusive ni. Diorang are independent. A, B, C. Okay. This is the answer. Okay. Okay, next example. There are 60 students in a certain college. 27 of them are taking mathematics, 20 are taking biology, 22 are taking neither mathematics nor biology. Find the probability that a randomly selected student takes both mathematics and biology. Number 2, mathematics only. Okay, they are. Okay. So we are just have the information of total of students taking maths 27, 20 are taking biology, 22 are taking neither maths nor biology, 22 outside. Okay, if we sketch it in a Venn diagram, okay, so 22 is not taking mathematics or biology. Okay, based on the question, we need to find the students who are taking maths and biology together. So in our imagination, okay, in our imagination and understanding, mathematics and biology will overlap to each other because there will be a students who are taking both based on the question, kan? There will be begini. But we don't have the information, so we will let the number will be X. Macam inilah. Okay. X number of students taking both, and then mathematics 20 minus 7 for this part. Okay, and then biology 20 minus X, so 20 minus X is the students that taking biology only and not maths because we already minus X kan yang ambil maths tu. Okay, so 22 is outside, so total of students is 60, so find the probability randomly taking both maths and biology. So from here we can have value of x, kan? Value of x, since we know all the values, all parts of the values, and we know that our sample space is 60, so 27 minus x plus 20 minus x plus 22 is equals to 60. So you can find x value. So x is 9. So when you get x equals to 9, barulah tadi dekat our graph tu, okay, so here is 9, maths and biology, here outside is 22, 27 minus 9 is berapa? 18, kan? And this is 11. Betul kah? 20 minus 9. Okay, 11. Okay, so taking both maths is 9 over 60. Okay, this answer simplify. And then second part of the question is asking you to have mathematics only. What is the probability who are taking mathematics only? Mathematics only. So 18 lah. Okay. Don't take the one who are taking maths and biology, because the question is mathematics only. Mathematics only is M intersect with B prime. Okay. Next one, kata apa soalannya? A student is selected at random. Determine whether the event taking mathematics is statistically independent of the event taking biology. We have to find, is it taking maths, probability of taking maths and taking biology is independent. How we can prove them independent? So what is the properties of independent? P M intersect with B equals to PM multiply with PB. Check lah this one. So PM intersect of B is 9 over 60. Are they equal? PM, so mathematics will be 27 over 60 multiply with biology 20 over 60. Did you get the same answer? Okay, did you get the same answer? It is equal, kan? 3 over 20. Begitu ya cara we check whether they are independent or not. Okay, so this is the conclusion. Independent event. So the one is independent, maksudnya if the event is independent, there are two types of event lah, independent and dependent event. Okay, dependent event usually the one with conditional probability that when you pick up pen or balls with different color, you are putting a condition that without replacement. Okay, so I think this one, the last subtopic, Bayes theorem, so I think I will discuss this in the class, but if I have time to make video, I think I make video first lah. So later on in the class, we just discuss the question that you are not understand or any mana-mana topics that you don't know. Okay, I'll see you on the next video, maybe a short video, because this is a very short slide. I think less than 20 slides for this Bayes theorem. Okay, thank you very much for your attention. I'll see you in the class. Okay, bye. See you.